So the United States has two unfinished AP1000 reactors, and it looks like they're finally getting finished. So let's see what has happened. I'm going to share some news with you today. It's not just AP1000 news, it's also molten salt reactor news, but let's begin. So the Brookfield assets has been picked to take over failed VC Summer nuclear project. And this is very important. I believe that Brookfield assets is like a company that owns Westinghouse, right? So the interesting bit here is basically that they say that they can start or restart the construction project and finally finish it, and then start making electricity at no extra cost for the ratepayers. It's also interesting because this was the sentence that I wanted to highlight. Let me make it bigger so you can read it. We need this capacity. The level of data center growth in South Carolina is enormous. They want clean energy, and this is something that we're going to look at later on in the video. First, the other news that I want to share with you is Terrestrial Energy. As many of you know, last time or in previous times when I made videos about Terrestrial Energy, people were accusing me of having stock in Terrestrial Energy, or having some kind of a stake in Terrestrial Energy. It's simply not true. I mean, I make 750 euros a month. I don't have any money to invest in anything. So if you want to support me, you can go to my Patreon page and become a paying member, or you can donate something via PayPal. It's in the description below. But in any case, Terrestrial Energy. I have been talking about terrestrial energy for ages now. And that's the reason for that is that the molten salt reactor has been my gateway into the nuclear world. I was looking for, better nuclear reactors that couldn't melt down and that would use thorium and all that stuff. And I got hooked on the molten salt reactor. And terrestrial energy from a fairly early when I was trying to figure out which of these molten salt reactor companies were legit and not, Terrestrial Energy really stood out to me as one of the companies that were really working on a solid business case. They were building their governance, they were doing all the engineering that was needed, and they flew relatively low under the radar. You also had Fly by Kirk Sorensen, you had Thorcon, and there were a couple of other molten salt reactor projects, startups that I thought, had some promise, but in the end, some of them finally made it to a point where you could say, okay, now they've become mature, and now there's a chance of the molten salt reactor actually getting built. Thorcon is the other one. They are trying to do it in Indonesia, and Terrestrial Energy is basically the one that has stuck with North America. First, they tried to commercialize their nuclear reactor in Canada. Then the situation became more favorable in the United States, so they basically moved their operation to the United States in order to make sure that they can actually start building these reactors soon. Now, the interesting thing here is that as of October 28th, Terrestrial Energy will be available on the stock market, the NASDAQ. So that's very interesting. Now, how all of this works, I'm not a financial person. I don't know a lot about stock markets. I do know about, supply and demand. I know that if you have a very good idea, you developed your IP, and you basically developed a product that can be sold onto the market, that conveys a measure of value, and people can buy stocks, right? They basically buy a little part of your company, and that's how money is made. Obviously, you make money once you actually start building reactors, and you start actually granting construction companies the license to build your concept. But in any case, this is very interesting. I'm not a financial person. I'm not giving you any financial advice. I'm really a nut for physics. I really love physics. I love energy, and that's why I want to talk about it. But this to me is a signal that the market is ready to start buying Terrestrial Energy's IMSR, Integral Molten Salt Reactor. And the reason why I am so enthusiastic about this particular nuclear reactor design is because it uses a liquid fuel. And I think that using liquid fuels, which is, all the other startups, I'm not talking about the molten salt reactor guys, except for Kairos, that's another boondoggle. Everybody is using solid fuels. All the high temperature reactors, the pebble beds, the regular old light water reactors, but also something like natrium, for instance. They're all using solid fuel, and it's fine to use solid fuel, but I want to see what is possible once we move over into the liquid fuel cycle, because to me it just looks like there's more options there. You can reuse fuel more easily, you can reprocess fuel more easily, and I believe that is what is needed in the nuclear world. Aside from that, I do believe that molten salt reactor cores, these are no longer reactor pressure vessels, because they don't need to contain any pressure. They're basically buckets filled with salt that has a moderator in the middle and some heat exchangers in the top, and that's basically it. I believe that these things can be manufactured. I still buy into the idea of the small modular reactor, where you actually build modules that you can transport over the road and that then finally come together to create a power plant, because that's how the gas industry did it, right? The only difference being that a nuclear reactor always requires containment. So there's always a load of concrete involved, right? That's the only difference. But as long as you make it as modular as possible and you basically ensure that the building blocks can be inserted quite easily, I believe that is going to be the game changer. We really need to speed things up, right? We need to get these reactors up and running within 2 or 3 years. And as things stand now, let's go back to VC Summer and talk about that, right? This is something interesting. If you're a stock market guy, if you buy stocks, I wanted to give you a heads up. This is something interesting. You might, you can look into. Personally, I'm very, very excited about this thing. I repeat, I don't have any stocks in Terrestrial Energy. I don't have any financial stakes in the company, none whatsoever. Just a couple of friends of me who work there, because I've been following them from the start, and that's it. So now we go back to the light water reactors, right? And we get hit on the head constantly with this claim that nuclear reactors take 15 years to build. This is not true, right? If you look at all the nuclear reactors that have been built over the past 60 years, let's say 60 years, 70 years, 75 years even, what you see is that we have about, 1/5 of all the reactors were built within 5 years. Then there's a huge chunk, which is about half or slightly more than half, of reactors that were built within 5 and 10 years. And then the remainder were construction periods that took much longer than 10 years, really failed projects, basically. So when people say reactors take 15 years to build, I always say that's not true. In the 1960s, we started building a nuclear power plant in the Netherlands. We finished it after 4 years in 1973, and it started operation, and it has been in operation ever since. We built that reactor in 4 years, and that's basically with 1960s technology, right? So an AP1000 is not much more complex than 1960s technology. I have been inside the Borssele nuclear power plant, which is a 485 megawatt pressurized water reactor. It's a two-loop design, and it basically has a relatively old school turbine building, right? So the building where the power generation or the power conversion equipment is installed. If you go through that building, you're ducking all the way and you're trying to get your head around pipes and stuff. There's like 1 million pipes in there. And I believe that more modern turbines, more modern power conversion buildings, generator buildings, are less complex than that one, right? Ever since the 1960s up until now, we've become better, more efficient at building these things. Although, if you look at the time frame that it takes to construct an entire nuclear power plant like an EPR or an AP1000, let's take Vogel as an example, it's like these things have become more complex and we have become more impotent. We have become less good at building these things. But I do believe that that is now going to turn around. And let's hope that VC Summer, which is already pretty far in the construction, the construction has been, they did construct it for nearly 9 years at one point. So there's a lot there. It's just not finished. So let's hope that they can finish it relatively quick. Let's say in 3 or 4 years. I don't know what the time frame is that they have in mind. But in any case, if you look at this, I asked ChatGPT, can you give me a 10 bullet point synopsis of the VC Summer AP1000 project? And yes, it's VC Summer. It's not VC Summers. And then you get this, in 2008, Scana and Santee Cooper constructed Westinghouse for 2 AP1000 reactors. In 2013, they started construction. So they haven't been building it for 9 years, but they have been building it for 4 years. Basically saying that the modular AP1000 approach faced supply issues 2014 to 2017, repeated manufacturing defects, schedule slips, and escalating cost estimates. March 2017, and this was the big one, Westinghouse filed for Chapter 11 bankruptcy under massive losses from U.S. projects. So this is basically VC Summer and Vogel. It's 4 AP1000 reactors that were basically drowning them. They couldn't bear the financial burden of this nuclear power plant, of these 4 construction projects. In 2017, Scana and Santee Cooper abandoned the two AP1000 units after $9 billion spent. And then the collapse triggered Newgate, which basically ended. I believe that some people actually went to jail over this. Lawsuits, executive resignations, and settlements. Then what happened is basically, if you go there today, I bet that there's activity now that you can see people moving stuff around again. But it has been basically a dead zone for a couple of years. Yes, there's Unit 1, a pressurized water reactor, which is up north, which is still in operation, so that's fine. People are still working there, but slightly to the south, that's where the 2 units were being constructed. That's basically that was basically abandoned. So what we've learned in the past couple of years is that there are several instances, companies that were talking about reviving VC Summer. Basically, as if you look at Georgia, for instance, I believe that they expected that their energy demand would go up from 8 gigawatts to like 20 gigawatts just for data centers alone. I mean, this nuclear power plant isn't that far away from it. I believe that it is South Carolina, right? We'll see it on a map in a minute. So what you see is the data centers are basically popping up everywhere, and I do know that there's plans for data centers in the vicinity of the VC Summer nuclear power plant. So come this week, we get this over here. Brookfield assets picked to take over failed VC Summer nuclear project. Basically, finding somebody who's willing to basically take up where the prior builders, the prior owners left off, and finally finishing the project and making sure that electricity can be generated from this reactor again. So in essence, this is basically now a done deal. That doesn't mean that the reactor has been restarted. I mean, they still need to build them, but in any case, it's a good sign. So let's go to my favorite map. This is the map that I've been working on for a long while now. As you can see, it's becoming pretty crowded in the United States. It's basically a map where I'm focusing on the big tech stuff. So I'm focusing on the data centers and how the data centers tie into the electricity grid. I'm trying to find data centers and see how they are connected to the electricity grid and how far away they are from certain power producing assets, gas plants, coal plants, nuclear plants. And so let's concentrate on VC Summer, right? So over here you have South Carolina, and you have Georgia. I believe that Georgia, that's Vogel, right? So Vogel is over here. This is the AP1000, the two AP1000s. These are the two AP1000s that are finished over here. So you have Vogel 1 and 2, and then you got Vogel 3 and 4. Both of them are in operation today. As you can see, there's smoke billowing out of one of the cooling towers, indicating that power is being produced in this unit at this moment when this satellite picture was taken. So we know that the technology works. We know that we can build these things, right? So over here you can see the two AP1000s. So the interesting thing is that, and this is what I noticed when I was mapping, is over here, this is the Savannah River nuclear site, right? This is basically, oh, wait a second. Why did I fly away? Well, let's get back to there, right? So this is basically where the United States does a lot of the nuclear deterrence stuff. The Minutemans and the bombs and everything. There's over here. Over here, this is basically one of the only operational plant in the United States where they I believe that they produce tritium and pack the tritium up, and the tritium is used in nuclear bombs. So you can see that this Vogel nuclear power plant is really close to this huge site with a lot of nuclear activities. But we're in South Carolina, all right? So let's go over here. Let's see. Yeah, this is it. So this is the VC Summer nuclear station, right? Virgil C. Summer nuclear station. So this is the first unit. It's a pressurized water reactor. Interesting bit is that its cooling water comes from this reservoir over here. It's the Monticello Reservoir, and as you can see, there's a dam over here. All right, pretty interesting stuff. So there's a dam, and this is what you see very often in the United States. Is where they combine stuff, right? If you have a dam, which creates a huge body of water, you can use that huge body of water as a cooling reservoir for a nuclear power plant. This is also interesting. This is another reservoir. Maybe this is like an emergency reservoir for if something is wrong with the dam. I don't know. It's pretty interesting in any case. So down here, this is where they are building VC Summer 2 and 3, right? I believe that this is 2 and that this is 3. And as you can see it, by the state of things, they literally dropped their work where they were. They left a lot of this stuff lying about, and that was basically it. Now, the interesting thing about these reactors is that a lot of the expensive equipment is already there. They're probably stored in these facilities over here. I don't know. They look like tents. Or maybe some kind of shelter. So we do know that for instance the reactor pressure vessels are there, the reactor heads are there, pumps are there. The heat exchangers, the steam generators are there. So a lot of the equipment is already stored on the site. Now, I suppose that first you need to clean up this place first, right? It has been subjected to the elements during all this time. So I can imagine that you first need to clean up, check what needs to be checked. By the way, this is also interesting. Over here, you can see these rings, right? These rings, and you can see these dome type things. That's basically those are part of the containment structure that are going to be placed on top of these elements and around these elements, and finally which constitute the containment building. So as you can see, a lot of this stuff is still here, and you can see over here as well, there's all sorts of contraptions and materials lying about, just waiting to be used. Now the question is, can you just pick this stuff up and use it in the construction? I don't know. honestly. They've been subjected to the elements, but on the other hand, if they were lying about and out in the open, maybe that's no big deal. I don't know. But in any case, so this is the VC Summer construction site where these two projects need to be finished. It's also interesting that each of these reactors is going to be cooled by these forced cooling towers, right? You can see these fans on the inside. They're literally blowing air past, I don't know, cooling stacks or something like that. Very interesting stuff. There's a huge switchyard over here, as you can see, because obviously you need to, you have this switchyard. There should be also, I mean, what you usually see over here. So there's 1, 2, 3, 4 turbines over here. So you also have 4 generators, and then you get this power conversion equipment over here. These are probably transformers of some sorts. So basically, what I would do here is I would basically place a purple figure around this here, and then call this the power conversion spot. Now, unfortunately, the color below is yellow, so I don't know if that stacks with the purple, but if it does, I'm sorry. So yeah, this is a very interesting site, and there was one other thing that I noticed. There's a small gas plant over here as well, and the reason why I want to basically talk about this small gas plant is the following. So if you have a nuclear power plant by itself, could you start it? That's the question, right? And the answer is no. Many people don't get it, right? You could start it if you have like auxiliary power production. The emergency diesels normally they only provide power for the pumps, or they provide power for the critical systems alone. But the point is, this is a huge building, right? And if there's no electricity in the building, you can't operate the nuclear power plant. So having one of these tiny gas plants over here basically provides the starting capacity that you need in order to get the nuclear reactor started. Now, on the other hand, you also have a hydro dam here with some generators, so you can also run your power plant of the electricity that comes from the hydro power station. And the same counts for these AP1000s over here. But that was one of the interesting things that I noticed. Now, the interesting thing about the AP1000 is that they have several COLAs, right? So what is a COLA? It's a construction and operations license application, right? Which means that you basically have shown to the regulator that you know how to build these things, that you know how to operate these things under all conditions, and that you've satisfied the regulator to such a degree that they say, okay, here is your license, you can construct a nuclear power plant, and once it's finished, you can operate it. There's a couple of other COLAs out there that are still active. So this is one of them now, right? So this is the William States Lee III power plant, or should be the William States Lee III power plant. But as you can see, nothing is there. The project never was realized. There is like this small utility over here. It says W.S. Lee NPP warehouse, basically indicating that this is the site where they would like to build another set of AP1000s, right? And then let's see, because there's another electricity symbol. It's down here, down the south. That's over here. Forgot the name. This is the Lee. No, the William States Lee is in top. Did I? Oh, yeah, there it is. Levy 1 and 2. So Levy 1 and 2, there's also a construction license for Levy 1 and 2. So basically 2 AP1000s in Florida somewhere. But again, everything fell through and they never started it. It's pretty interesting because there's a small power plant over here, a gas plant over here. There's a huge or a pretty big coal-fired power plant over here, the Crystal River power plant. And then over here, there's this Citrus Country combined cycle plant. As you can see, I've drawn up a lot of symbols on this. If you would like me to explain to you what is going on here, please let me know in the description below, or in the comments below, so I can tell you what is going on. But in any case, I mean, there's I believe there were last calls for in total 8 or 10 AP1000s. I do know that the United States wants to build 10 AP1000s, but there's also like a huge project here near Amarillo, which I'm going to make a different video about, because it's too big to just handle in one video. This video is now 25 minutes long, and you know, we can't go on for an hour just to make you watch. So in any case, I think that something really interesting has happened with VC Summer. I also think that something really interesting has happened with Terrestrial Energy. Those were the two news items that I wanted to tell you about. If you want to support the channel, please make sure that you subscribe down below. I mean, it's free. You can just press the subscribe button and you'll get a notification whenever I make a new video. Like the video and share it with your friends, obviously. Leave a comment. Seriously, I read all comments, and if I feel like it, I also respond to most comments. And if you want to support me financially, you can do so over at Patreon, or you can do so using PayPal, for which you can find the link in the description down below. Well, thank you all very much for watching, and may the strong force be with you. Bye-bye.